How is the world's climate changing? Is mankind responsible for those changes? How can we adapt to climate change? And how can we avoid the worst consequences of global warming in the future? I'm Met Office meteorologist and presenter Aidan McGivern. The best place to find answers to those questions is in the latest UN climate report. This is the sixth assessment report from the Intergovernmental Panel on Climate Change, which brings together and synthesises all the available current climate science. But the second best place to explore this report is right here. In the next 20 to 30 minutes, I'm joined by two experts from the Met Office who were also lead authors on first and second instalments of the report. Dr. Chris Jones, a lead author on the first instalment of the report, The Physical Science Basis. Professor Richard Betts, MBE, lead author on the second instalment, The Climate Change Impacts, Adaptation and Vulnerability. And from Exeter University joining us is Dr. Anna Harper, who is an expert on vegetation and climate change. Thank you for joining us. Before we talk about what the report tells us, how the climate's changing, how it's expected to change in the future and what we can do about it, just if you can, Chris, summarise what kind of evidence does it bring together about how the climate is currently changing?
Yeah, thanks, Aidan. So, the report, like you say, is huge. It summarises all of the climate research and science that the world has been doing over the last sort of few years. Part of that evidence is looking at what's changed. So we know that the global temperatures have increased since pre-industrial. So the report says the last decade was about 1.1 degrees centigrade above pre-industrial levels. So that doesn't sound much, but we know that's having big impacts on everywhere at the moment. So we're seeing a rise in sea levels. So they've risen by about 20 centimetres, but that's started to accelerate. And we're seeing more heat waves, droughts and floods than before. And increasingly we're able to attribute those to an increasing risk of those, at least from climate change.
And Anna, is the global warming that we're seeing increasing? Is it accelerating?
We know that each decade is getting warmer and warmer. So, for example, the 1980s was the warmest decade on record since pre-industrial times. And then the 90s was the warmest decade. And now to the last decade, the 2010s, they were the warmest decade on record since pre-industrial. And we're definitely feeling that warming on land. So the land surface warms up more than the ocean. So over the past, since pre-industrial, the land surface has warmed up by 1.6 degrees compared to the global mean of 1.1. So we're feeling it on land. And there's definitely been lots of extremes, which is also something that scientists expect with climate change. We expect to see more extremes with heat, with droughts, with floods. And we've been experiencing those definitely over the last few years. I'm sure everyone can think of a few examples from their recent memory, like the last summer in the UK, for example.
Yeah, we're seeing these extremes, and 1.1 Celsius global warming doesn't sound like much, but we're seeing big impacts around the world as a result, aren't we, Richard?
Yeah, so every part of the world is now seeing an impact of climate change, both on land and in the oceans. So in the natural world, we're seeing in particular signs of spring coming earlier, so leaves coming out on the trees earlier in the year, flowers blooming earlier, migratory birds arriving earlier and so on. But these are happening at different times as well, which is potentially disrupting the ecosystems. In terms of people, places we live are being increasingly impacted by extreme weather events, many of which are being made more severe or more likely by climate change. We're seeing threats to health from high temperatures. We're seeing changes in the water system, which is impacting on water security. So many places are getting more severe drought. Some places are getting less drought, has to be said. It's quite a complex picture, but some places are getting more intense rainfall, which is increasing the risk of flooding. So we are seeing impacts all around the world.
Some people, Chris, would say, well, this is a natural cycle. This is, it's to do with, coming out of an ice age, or it's to do with solar cycles or whatever. How can we be sure that mankind is responsible for this global warming?
Yeah, so there's a huge body of science that's trying to answer exactly that question. And we know, climate can change naturally, changes in the Earth's orbit. That cycle in and out of ice ages typically takes 100,000 years. And we're seeing changes now over a few decades. So it's much, much faster. It's, 100 or even 1,000 times faster than those long-term changes. And what we can do with our kind of climate models is we can look at how the world would change due to different things. So things like changes in the power of the sun or volcanic eruptions. We know they might have had a small impact at the beginning of the 20th century, But since about the mid-20th century, all of the warming we're seeing is being caused by greenhouse gases accumulating in the atmosphere, and they trap some of the sun's heat, so they stop heat escaping back to space. And the basic physics of that, how that happens, is well known and well understood in these models. So we can be pretty sure about that attribution.
So there's a lot of research,
Yep.
and it rules out natural factors. Mankind is solely responsible for this current level of climate change, of global warming. I mean, the research is phenomenal that goes into this report, isn't it? It's tens of thousands of publications. The knowledge from those publications are brought together by hundreds of scientists around the world, and this is signed off by governments around the world as well. So it's unequivocal that climate change is happening, and mankind is responsible. So the important question to come to next is what we do about it. Are current global policies enough to tackle climate change?
They're starting to have an effect. They're not enough. So one thing that the report is clear about is that current policies are beginning to reduce our emissions. So we're not on track for some of the really catastrophic levels of warming that maybe we're warned about. But they're also not on track to meet some of the goals. So we'll know the Paris Agreement aims to limit warming to below 2 degrees, hopefully even towards 1.5 degrees. And there's still a gap between, our current policies and the policies required to actually reduce carbon dioxide emissions to a level consistent with that.
So the Paris Agreement back in 2015, as you say, we want to keep warming below 2 degrees, ideally below 1.5 Celsius. And to do that, what do we need to do with emissions?
We've got to really act urgently. I think that's the key. That's one of the big changes, is the urgency of the situation. So we've known for a long while we need to reduce our emissions, but the longer we leave it, the more urgently we need to cut. So, there's a very simple physical relationship that the more we emit, the more the world warms. And if we want to stop the warming, we have to stop emitting. So that's known as net zero. There are still pathways that we can follow that will lead us to within 1.5, but we need to halve our emissions by 2030. So that's only a few years away. And we need to kind of get rid of them completely. So the world has to reach what we call net zero by 2050 to stay within that 1.5 degree target.
7 years to halve emissions around the world, a very ambitious target. What exactly would happen if we exceeded 1.5 Celsius? Because we hear a lot about this 1.5 Celsius target. Richard, what happens if we go over that threshold?
So there won't be a sudden change going past this threshold. It's not really a threshold as such. It's not a point in the Earth system where it's not a tipping point or anything. It's a target. We want to stay below that warming if we possibly can. It's looking increasingly unlikely. If we do go above that, the impacts will get more severe. But it would still be worth working hard to limit warming to as little above that as we possibly can. Still aiming to limit warming to well below 2 degrees. We will see increasingly severe impacts as we go beyond 1.5 degrees. Warming will have to be adapting to those. We may in the longer term want to try and bring temperatures down again if that's technically possible, but in the medium term we'll have to live with the changes that are already locked in, and increasingly so as we exceed this target.
There's a danger, isn't there, of the unknown. Once you go above 1.5 or above 2 degrees, the further up you go, there are increasing unknowns, and some of these are tipping points, aren't there? Are there any tipping points that you are particularly concerned about if we exceed 1.5 or if we exceed 2 degrees?
In terms of the longer term impacts, which may be kicked off soon, a long-term melting of the Greenland ice sheet is the one which is sort of perhaps most likely to be initiated at lower levels of warming, around about 1.5 degrees warming. This is one of the reasons why the Paris Agreement increased the ambition from limiting warming to 2 degrees, as in the old agreement, to 1.5, because 2 degrees was thought to be not ambitious enough. It could well be that you reach a point where the ice sheet on Greenland starts to melt irreversibly, not too far above 1.5. It's very uncertain. The risks increase the higher you go. So that's, for me, that's the one which we need to keep an eye on the most, I think.
Yeah, that's why every fraction of a degree above 1.5 Celsius matters so much, because there are these unknowns. We don't precisely know what temperature that irreversible warming of the Greenland ice sheet, the irreversible melting, could happen. Of course, once that's melted, very difficult then, even if you come back down below the temperature at which that happens, very difficult to get the ice back on there.
It's probably worth saying that this would still take a long time to happen. It would take centuries for it to fully melt, or even millennia. But the point is, you'd be committed to a long-term sea level rise, so future generations would find this unavoidable as a result of what we've done now.
Yeah, and speaking of sea level rise, that's going to continue for a long time, isn't it? Even if we stop polluting right now, seas are going to rise for hundreds, if not thousands of years to come.
Yes, it takes an ice sheet or a glacier a long time to fully respond to an increase in temperature. So even if we stabilise warming at, say, 1.5 degrees, then mountain glaciers around the world would continue to melt away until they've gone completely, which would take decades to centuries. The ice sheets, as I said, would take even longer, but the point is it would be committed. So sea level rise is going to continue, and we are going to have to adapt to that. But we can avoid even worse sea level rises if we reduce emissions urgently.
Yeah, so we need to act now. Obviously, there are lots of benefits to acting now. What kind of benefits, other than avoiding the worst possible consequences of climate change, do you think there are, Anna?
Other than the impacts of the climate change itself, we talk about how on the land surface, forests and peat and permafrost and the high latitudes, these are all ecosystems that are storing vast amounts of carbon. And if the climate warms more, then the carbon in those ecosystems will be released, and that will accelerate climate change. So, avoiding those increases in climate change benefits the ecosystems and also benefits us by preserving this stored carbon on the land surface. And everyone knows, I think, how important things like forests are for our own physical well-being, for biodiversity, for providing other things like sustainably harvesting timber in certain places where that's appropriate. So protecting ecosystems benefits us and the climate, and so that's a step that we can take for mitigation that has multiple benefits.
Yeah, so it's not just about preventing the worst consequences of climate change and extreme weather in the future. It's about protecting ecosystems, biodiversity, preventing further mass extinctions, and of course it's economical to act as soon as possible, isn't it, Chris?
It is, yeah. One of the other things this report identifies are all of the options that are available to us, and there are so many things we can do now that reduce our emissions and bring co-benefits. Wind and solar energy are cheaper than they've ever been. Electric vehicles, I think in Norway, 80% of new vehicles now are electric. So, this new technology is really catching on. It's going to need proper support to make that infrastructure work, but it's, all these things are available, and they have other benefits as well. They massively improve air quality in urban areas. For example, we know a lot of cities have congestion charges, right? With electric vehicles, you wouldn't need those. So, so there's all of these things that come along with it, health benefits to, education and sustainability more globally as well, not just in the UK, but thinking about, benefits of, green development in other countries that bring clean energy, for example, to developing countries. These are all kind of loads of opportunities in front of us. We just need to grasp them.
Yeah, and the sooner we act, of course, the less painful economically it will be in the future. Sort of like fixing a leak now to prevent a flood in your kitchen in 10 years' time. Would you say, Richard, that it's down to individuals, down to businesses, down to governments, or everyone? Everyone needs to get involved.
It's down to everybody. There's a lot we can do personally. Changing your mode of transport, for example. Either buying an electric vehicle or not having a car at all. Just getting out on a bike or public transport or whatever is one thing. Changing diets as well is increasingly popular. Eating meat, especially beef, leads to a lot of emissions. So the less meat you eat, the smaller your carbon footprint overall. So those are things you can do at a personal level. Also reducing food waste as well is something that you can do as an individual, because when food waste gets buried in landfill, again it releases methane, which is a greenhouse gas. So you can do things individually, but really you need a system to change around you. You may want to cycle more, but you may feel unsafe on the road because the road network is just built for cars and not bikes. So there you need system level change. That needs action by governments and local authorities. In terms of energy and so on, you may choose a green supplier. It may be more expensive, but you need the infrastructure for green energy to really work as well. So system level change and individual change is all needed.
Yeah, and to meet that 50% reduction in global emissions by 2030, of course, big challenge. But at the same time, we need to think about adapting to climate change. I guess not just adapting to future climate change, but adapting to present day climate change, Chris.
Yeah, I mean, as you say, the world is already seeing lots of impacts everywhere. So, we are starting to adapt to them. The Thames barrier, for example, is built to withstand certain levels of flooding. People are starting to adapt to these things. But what's clear is adaptation on its own isn't enough. So a lot of the things we can put in place to adapt to a changing climate will become increasingly limited. They won't be effective as climate changes more and more. So we need that dual approach of adaptation, so putting things in place to cope, and mitigation, which means reducing our emissions and stopping the problem getting worse. So we need to do both.
And Richard, when we're looking at the future, should we be adapting to a 1.5 Celsius warming, or should we be thinking about 3 or 4 Celsius of warming?
It very much depends on exactly how far out you're looking. So if it's kind of day-to-day, year-to-year things, like a lot of farming, for example, you probably can take it a year at a time and perhaps plan for. We should at least obviously prepare for 1.5 degrees warming. We're going to, if we don't, even if we stay below that, it's going to be a very narrow, but it's increasingly likely we're going to overshoot that. So that's the bare minimum we're looking at. But for the longer term, if you're putting in place long-term plans like building new reservoirs, for example, for increased water security, that might take 30 years or more to put through. Flood defences and so on, the Thames barrier, these things take decades. So it's worth taking a more kind of hedge your bets kind of approach and look at what are the high level changes are and make sure you're at least not excluding the possibility to adapt to those if you have to.
Sure. And I worked with you on a video that looked at a potential heatwave scenario in the year 2050. That was back in 2020. And we talked, I was shocked at the time to be talking about 40 degrees plus in a UK summer heatwave. And that was looking ahead to 2050. And then, of course, in 2022, 40 degrees happened in the UK. Were you surprised it happened in 2022?
Not so much, because we've been saying that these things will happen sooner or later. It was quite hard hitting though to see the consequences of it. We know it's all about kind of statistics and so on, and as a scientist you're looking at how the odds are changing, but when you see it in front of your eyes and you see the rail network disrupted because the rails are buckling because of the heat, you see wildfires running out of control. Even in the suburbs of London you see streets of houses burning down because of the incredible heat means that some fire has gone out of control and so on. That really brings home to you that climate change is having these impacts, and it's having these things which are really starting to catch us out. We weren't prepared for these fires. Even though we knew in theory they could be starting to happen, the country was not prepared. We need to be more prepared for that kind of thing. That's
the thing, isn't it, Anna? We got a lot of comments when we put out extreme heat warnings for that heat wave that, other countries cope with this kind of heat wave. But of course, those countries are adapted to that kind of heat. And even in countries that are adapted to that kind of heat, they had extreme heat warnings. So, for example, we had them in Spain and Portugal with the same event, because everyone is experiencing an increased level of heat compared with their natural climate. So it's clear that we are not that well adapted to the current climate change, and we need to think hard about how we adapt to the next few decades.
Yeah, and that's right. And we've talked about global mean temperature changes. We're looking at a global mean temperature change of at least 1.5 degrees, but that's the average over the year for the whole globe. But you have these extreme events that happen. Another heat wave that was really striking was in 2021. There was one in the Pacific Northwest. And I mean, I feel like Seattle maybe has a kind of similar climate to a lot of places in the UK, and their previous high record temperature was 37 degrees in Seattle, and they got 42 degrees. So just imagine if all of a sudden we had a day when it was 5 degrees warmer than what we were used to. And now we've seen that that's possible. So we really do need to be preparing for these kinds of extreme events that could happen.
Yeah, I mean, it's just eye-opening that 1.1 Celsius of global warming could lead to such extremes around the world when you think about the potential for further warming in coming decades. Just to end on something positive after some doom and gloom covered in the previous 20 minutes, what are you hopeful about in the next few years, decades, and so on, Anna?
So I teach at the university, and I teach about climate change, and sometimes I give guest lectures about what kind of climate changes are we seeing, and it is really depressing. It gets a bit doom and gloom, and I sometimes end my lectures by talking about the changes that we've seen since pre-industrial. So if you think about scenery out, we're in Exeter, so around Exeter 150 years ago would have been a very different landscape. It would have taken days to travel to London, and people were working, day-to-day farming for their food, and they would have never imagined the world that we live in now with all the technology that we have and how relatively easy our lives are. And I'd like to think that humans, we haven't become less innovative since then. We're still really creative, and so to me, that's the hope, is that we can keep creating. I mean, we need to take these challenges seriously, but I think there's also tremendous opportunity in creating a new world, where we can both adapt to and mitigate the climate change that is being predicted.
Yeah, technological innovations and a big challenge in the years to come to halve emissions. But it's still possible, Richard?
It is, yes, and I prefer to turn hope into motivation. There can be this better future, but we have to make it happen. And in terms of halving emissions, the IPCC report has shown that the solutions do exist now in all sectors, in energy, transport, food systems, and so on. It can be done if we get on and do it, but we have to get on and do it.
Yeah. Do you think we'll do it, Chris?
I think we will, yeah. I mean, that reminds me of a story, I can't remember who wrote this, but somebody said, imagine you're sitting watching TV and you smell smoke from the kitchen, right? You don't sit there and go, oh, that's depressing, right? You jump up and you do something about it, right? And that's where we're at, right? We're at a stage where, the future is in our hands. Tomorrow's warming hasn't been emitted yet. We're still in control of that destiny, and there are policies in place. We're seeing increasingly, people talking about climate, a lot of activism, particularly in young people, and they're the next generation of leaders. So yeah, I'm optimistic we'll do something. I just hope we do it soon enough.
Yeah, time is running out, but we still have time.
Yep.
Optimistic note to end on. Thank you, Dr. Chris Jones, Professor Richard Betts, and Dr. Anna Harper.